Our group want to present about ARMv8 Cortex processor architecture, and the lecturer name is Fatin Nadirah binti Zamani. This is our group member. First, this is our group leader, Muhammad Zaidi Daniel bin Farzis Hairi, and the second is me, Muhammad Shafiq bin Zulkarnain, and the last one is Muhammad Adam Fikri bin Abdul Rahim.
ARM processor is one of CPU-based family developed by Advanced RISC machine, or to be called ARM. ARM makes 32 bits and 64 bits RISC multi-core processor. It supports data type of 8 bytes, 16 half word, and 32 words bit in length. The ARM architecture has a fixed length instruction, there are good speed, and a high code density. For the ARMv8 that we choose, it was first announced in 2011. It was introduced in two types of execution state, which are 32 bits AR32 and 64 bits AR64. In this ARM architecture, there is a component series that are a component that are called Cortex series. There are three types of main family in this Cortex series, which are Cortex-A, Cortex-R, and Cortex-M. For Cortex-A, it generally used for an application device computing, application level computing in device like smartphone and tablet. It's more into a performance feature. For Cortex-R, is designed for real-time application that are include that about safety system, like they are used in car. And then the last Cortex is Cortex-M. They are used for mainly for a low power system and microcontroller device. So for these three types of Cortex, each of it are different use.
Okay, right now I would like to talk about the ARM Cortex-A73 processor. Core execution unit. Branch unit manage branch operations such as jumps and loop using a branch prediction to minimize pipeline stall. So the branch unit acts like smart GPS, predict a code, path, and overlay. Advanced neon. 128 bits vector processing unit for multimedia electration for video and audio. Floating point unit PFU handles floating point calculation to make it simple. PFU handles precise math for graphic and AI. Register file ED register file is a temporary tagging for record and execution state. ARM register file permanent storage of architectural register state. ALU plus is enchanted metric logic unit to support complex operation. IDIF and MAC. IDIF integer division unit, MAC apply accumulate unit. So IDIF and MAC specialist for division and multiplication. Instruction management. 1. Decode. Breakdown ARM thumb instruction into micro-ops, like breaking a recipe into steps. Second, dispatch issue. Routine instruction to the appropriate execution unit in order to execution. Assign a task to the right unit, like a project manager. Third, AGUs. Address generation unit. This can help calculate memory address for load and store operation. Fourth, load or store unit. Manage memory access. Use STB buffer for write operation. Manage data traffic using a smart buffer system. Cache and memory hierarchy. 1. Instruction fetch. Fetch instruction from the 64 KB L1 I cache. Second, main TLB. Translate virtual to physical address for cache access. So it acts as the address book for quick location tracking. Third 32 KB or 64 KB L1 D cache. Figurable data cache, the fast access front desk. 4. STB, or we can call it data store buffer. Temporary buffer for depending memory write, and temporary holding area for outgoing data. 5. Share and to cache. Share cache, typically 256 KB until 8 MB across all core in the SOC. So for the next slide, I would like to talk about ARM Cortex-A73 data pipeline flow. So data pipeline flow has three categories. First, front end stage, which is instruction executions. Second is mid-core stage, which is execution. Third is backline stage, which is completion. So right now, I would like to explain how the Cortex-A73 processor works using a simple analogy. So you can imagine that your phone processor is like food restaurant. So first, taking orders. Taking order is front end, which is stage 1 until 5. Stage 1 until 3, our cashier or fetch unit, we can call it, take your order. First, they check the menu, which is, we can call it L1 cage. Then prepare your order slip, which is instruction alignment. Second stage, 4 until 5. Now our kitchen manager, or we can call it the code unit, we break down your complex order into simple steps. Assign unit, order, number to avoid mix-up. So we can call it register renaming. Second, the activity is cooking the meal. Or the stage, the category stage, we will call it mid-course stage. This stage has, this stage is from 6 until 10. Now, our kitchen staff jump into action. Stage 9 to 7, the head chef, or we can call it dispatch unit, assign a task. Burger flippers, or we can call it ALU, handle a basic map. Fried cook, or we can call it neon, process multiple items at once. Bakers, or we can call it FPU, can handle precise measurements. For the stage 8 until 10, our logistics team, or we can call it AGU, find ingredient fast. How we can call it gauge as find then use tagging area store buffer for complete item. Then some special ingredient take longer take longer fetch. So this is for the L2 cage. Third, order delivery, or we can call it the third categories of the pipeline data flow, but and stage 11. So finally our quality control. Stage 11 package up to 2 meals per cycles. So our manager or we can call it Snoop unit control, ensure all delivery riders are coordinated. That's all.
The image shows the Cortex-A73, a high-performance CPU design developed by ARM, known for creating energy-efficient processor and used in mobile devices. ARM doesn't manufacture chips, but licenses its design to other companies. One of the companies is Qualcomm, which is used a semi-custom version of the Cortex-A73 in its Snapdragon 835 processor called Curio 280. This processor offers a good balance of performance and power efficiency suitable for smartphone and portable device. The Snapdragon 835 was produced by Samsung using 10nm LPE technology, which is allows smaller chip sizes, lower heat, and better energy efficiency, making it ideal for modern mobile device. On the left, we have the Samsung Galaxy S8 and S8 Plus, which are popular flagship smartphones in markets like the US and China. This device uses the Snapdragon 835 processor that is optimized for reduced heat and stable performance. The phone also supports fast charging and comes with the powerful Adreno 540 GPU, delivering impressive 3D graphic performance. This makes them suitable not for only daily use, but also for heavy gaming and multimedia tasks. Thanks to its high efficiency, users enjoy smooth reliable performance in a sleek and compact design. Thank you. On the right side is the Samsung Galaxy Book 10.6-inch Windows 10 LTE model. This laptop also uses the Snapdragon 835, showing how the same mobile processor can power Windows laptops. It offers strong single-core and multi-core performance for productivity, good graphics for media and gaming, and excellent power efficiency with its 10nm design. The Galaxy Books provide up to 11 hours of battery life for video playback and feature a fanless design, ensuring silent operation without overheating. The last image shows the Oculus Quest 1, a popular standalone VR headset that runs without need for a PC, wires, and external sensors. It is powered by a modified version of the Snapdragon 835 processor, which is used ARM Cortex-A73 architecture. This mobile processor, combined with the Adreno 540 GPU, provide enough performance to run high-quality VR games on and apps. One of the key features of the Oculus Quest 1 is its upgrade cooling system. This helps prevent the device from heating even during long intense gaming session, ensuring stable and smooth performance. Despite being powered by a mobile chip, the headset is capable of running popular VR titles like Beat Saber, Super Hot VR, and Robo Recall, delivering an immersive gaming experience.
For summary, the Cortex that we choose A73 is as you know, designed for mobile device with a great performance and power efficiency. It has 11 stage in order pipeline. They are used to save more power than out of the other device. Like previous device is Cortex A72. It is 30% faster than the Cortex A72. So the memory system is improved with a larger cache and can store buffer to reduce delay. This is built for more for performance device and high efficiency, and it also included a low power use. Okay, this is our reference. We have from website and YouTube. So that's all from our group ARMv8. Thank you, everyone.